Welcome back. We're going to look at the moon today. So the race for the moon, how that man has landed on the moon, the fascination with the moon over the ages, and then the actual topography of the moon, essentially the Earth science, but it's not the Earth. It would be how the moon is, what's the structure of the moon, what are the geographic, topographic features. So let's look at some. I imagine that the moon has always had an attraction to the imagination of men. Men have always been able to look up in the moon and see the face that appears to be in the man in the moon, and even imagine themselves being on the moon. The various earliest silent movies showed people exploring the moon and that there were little aliens on the moon. So it's part of our folklore, and it's part of what it means to be human, that we wanted to explore. And the moon is in our very backyard, and so this would almost be like camping out when you're 7 in the backyard. It's part of taking your exploring as part of what makes a man a man. So in any case, the moon has been investigated ever since Galileo was the first to look at the moon and make maps of the moon through his telescope. And lots of exploration has been made by telescope. But in the early mid-20th century, lunar probes started launching from the Earth. The first one was in 1957, and the Russians were the first to have a probe into space. It really set off the Cold War in earnest. People were very afraid of what the Russians were doing with satellites that could go over their countries with nothing that they could do about it. And also the idea that if you could launch a space probe, you could launch a nuclear weapon because it's the same technology. And so the race for space was really on. So the moon was explored, I believe, earlier than it would have been, simply because of the competition of the Russians with primarily the United States, the West in general, during the Cold War. So that first cosmonaut was the first cosmonaut was Kurgan, I believe. Andrei Kurgan, I think his name, Kurgan. He was the first to be in space. Later that year, there was an American, Alan Shepard. He became the first to be launched into space, and then they started several man crews until eventually the end of the 1960s. America won the race for the moon. They were the first to actually land a man on the moon, and you had Neil Armstrong and Buzz Aldrin that actually walked on the moon. There was a three-man crew, but only 2 of them actually went out onto the surface of the moon. I believe that even NASA again would like to go where man has already gone and go to the moon, even making a lunar base perhaps, something that could act as a fix-it shop or a place that would act as a substation to be able to go further into the solar system or beyond. So that's all in the future, of course. If to study the moon, you're going to see that there's some dark areas of the moon. There's also some light areas of the moon. A lot of this is just topography. The light are the highlands or the mountainous regions, and then the Maria are these flat plains. And you're going to see that Maria mostly is like a volcanic plain where that has been cracked and essentially oozed with lava that covered in these plains called Maria. Maria is Latin for oceans or seas. You can also see lots and lots of crater marks. There's no atmosphere on the moon, and so any meteors would simply impact the moon and then not disturb. There's no wind, there's no weather, since there's no atmosphere, so there's nothing to blow it around. You are going to see that there is some solar wind. Now, solar wind is not actually wind. It's not like blowing air like we know because there's no atmosphere, but you do have charged ions material that's being ejected from the sun, and the surface of the moon is very dusty, very pulverized, and for that reason there's not a lot of reflection. It's a very low reflective moon. Now, there's lots of times that the moon is so bright, shining through your window, that it looks like someone is in your driveway with their lights on. because of just how much light it seems to produce. But relative to other planets, the moon has relatively slow albedo. So an albedo is that light that's reflected. So what's the reflective surface of the moon? How much sunlight is being reflected off the moon to us? That's the albedo. Okay. Now, because of this, and especially because there's no atmosphere, the temperature differences are extreme. You can have between 270 degrees in the daytime. We're talking about a hot summer day as being 92, 93 degrees. And you can have daytime temperatures of 260 degrees Fahrenheit with nighttime temperatures at negative 280 degrees Fahrenheit. So because there's no atmosphere to modulate that or temper the heat, the differences would be scorching, boiling in the daytime and freezing cold at night. I already mentioned the highlands are these mountainous areas, and the maria are these plains, normally made up of some kind of basaltic lava. And then the rills, which look like little tiny valleys or little streams, are possibly lava tubes that have collapsed, and it looks like little stream beds, but that they have not found. You would imagine that it would be like water, but they haven't found. The craters, impact craters, are from meteors that have landed into that dusty soil and then ejected. So imagine throwing a marble into a tub full of flour. You're going to get these craters, and you're also going to get these other things. Ejecta is the stuff that came out of the hole and fell farther away, and then you can have these lines that connect the ejecta to the crater, and these are called rays. So you can have these rays as they're going along too. There's some really interesting parts as you study the moon. The moon is huge compared to the other planets in our solar system. The moons of the other planets, the natural satellites of the other planets, are teeny tiny compared to Earth's moon. Earth's moon is planet-sized. In fact, there are planets that are bigger than our moon. There are also moons in the solar system that are bigger than our Earth. But it's still the idea of, compared to the planet that it's around, it's the largest moon in terms of how massive it is and how big it is. It's also not made out of an ice ball. A lot of moons are ice balls rather than just rock, and so our moon is a rock moon. It's actually like a planet, and its orbit is farther. It's not as close as other moons of other planets in our solar system are, and its composition is the same as Earth, mostly silicates, just like Earth has. You can see that the rocks, when you were to collect the rocks they did during the lunar landings, have lots of breccias. And remember, that's a composite rock where it's made out of little pieces, little shardy pieces, pointy, triangular pieces of things. So imagine that if you have a big impact of a meteor, it created a lot of heat, and it fused together all these little pieces broken off from previous, along with the lunar dust, to fuse it into a new rock. So the moon is about the same age as the Earth in terms of that would have been the same time. The structure of the moon is similar to the Earth in that there's layers inside the moon. You're going to see that it's not exactly the same. You have, instead of a solid or one mantle like we have in Earth, there's basically an upper mantle and a lower mantle, where the upper mantle is thought to be solid, with the lower mantle being partially molten, kind of oozy, and then the core being also very heavy elements, just like Earth would be an iron core, so solid iron core. You don't have a magnetic field on the moon like you do on the Earth, so there's not a rotating iron the way that would be in the Earth. The Maria, remember, these dark plains or these dark patches, which are kind of oozy lava. And the theory behind it is, if you were to have an impact from a meteor or an asteroid that hits the moon, it would hit at such high speeds that it would crack the moon, and essentially lava would come up from the underside. The molten material would ooze into that area and then solidify, and that is what is made up of. It's made up of this basaltic plain, made out of just basaltic stone, the same way that the lava would be basaltic. There's no evidence that anybody can come up with that there's tectonic activity, no plates, no moving around. It's more of a solid crust, and the mountains would not have been created the same way that you would have along a side of a plate. So you don't have subduction type mountains on the moon. The moon would be the mountain formation would be in other ways, other reasons.